Hey guys, welcome to another video for 7A Math online class. This is second week of second quarter, and now we're going to go over 4.3 equivalent fractions and simplifying fractions. And as you can read in the bottom, I'm allowing calculators. Again, this is simple calculators, not the scientific ones, nor is it the what do you call that? Not the scientific one or the graphing calculators. Just simple calculators. The one that you can just add, divide, multiply, subtract, things like that. But not anymore, not any more high tech than that. Is the calculators that y- uh it's in your phone or in your computer, the default setting, okay, not the scientific setting. Anyway, let's talk about 4.3. I'm going off topic. So 4.3 is about fractions, and that's the reason why we talked about fractions last week. We reviewed about that 4 point. No, there's no 4 point. You just fraction review. So let's talk about equivalent fraction. So let's say suppose we have two pizza. One pizza is cut into 8 and one pizza is cut into 4. There's two guys. The first guy ate two pieces from the 8 slice pizza, and the other guy ate there's another guy and ate one slice from the 4-piece pizza. So the question is, did both guys eat the same amount of pizza? So how do we figure out if they're equivalent? Well, the most easiest way to do it is to draw, but I am a bad drawer, so I'm gonna apologize in advance. So here's the first pizza, and it's cut into 8 slices. Pretend they're all the same size. I know they're not. They don't look the same size, but just bear with it. So the first guy ate 2 slices, so we're going to shade 2 slices of pizza. And then that's the first guy. And then let's draw the second guy. Again, sorry about my horrible handwriting. My drawing skills is not really the best. And this is the second guy. So it's cut into 4 and 8 1 slices. And as you can see, they are equivalent. If I put this drawing over on this one, they will shade the same amount of area. And when they share the same amount of area, we call this equivalent fraction. So first of all, what fraction is this? This is 2 over 8, and this is 1 over 4. The 2 over 8 and 1 over 4 is what we call equivalent fraction, and the definition of an equivalent fraction is equal fraction, but they have different denominators. 2 over 8 and 1 over 4 are what we call equivalent fraction. Because as you can see, they have different denominators, but they are equivalent fraction. They're equal. They represent the same freaking thing, amount-wise. Now let's have uh, another example. Three friends ordered three pizza. One is cut into five, one cut into seven, one is cut into nine. If each of them ate their respective pizza, how much did they eat? Did they eat the same amount of pizza? Again, I'm gonna draw again. This is cut into nine. Pretend, okay? Pretend they're equivalent. This is cut into 7. And this is cut into 5. Now, since they eat their respective pizza, let me shade with a different color. Let's go green. Hopefully you guys are not colorblind. Shade, 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 shade. We shade everything. The first guy ate all of his pizza, so we shade all of it. The second guy ate all his 7 slices of pizza. So we select all of it. And the third guy ate all of his pizza too. The question is, did they eat the same amount of pizza? This is 9 over 9. This is 7 over 7. And this is 5 over 5. And as you can see, they are the same thing. This is all of it. They ate all of the pizza. This also ate all of his pizza. And this guy, the third guy, also ate all of his pizza. And if you put it on top of each other, there's going to be no gaps. You're not gonna, all of them will fill each other. You won't see the other colors. You get my point, hopefully. The essentially 9 over 9, 7 over 7, and 5 over 5 are equivalent because they represent the same thing. Recall, when we have a number over sum, they are all equal to 1. So 7 over 7 is equals to 1, 9 over 9 is equals to 1, and 5 over 5 is equals to 1. Now let's suppose we want to find equivalent fraction. How do we start finding equivalent fraction and you don't want to draw? Well, suppose we're going to take 1/4. Ignore that part. And we're going to multiply 2 on both the numerator and denominator. And what we're going to get is 2 over 8. We know that 1 over 4 and 2 over 8 are equivalent. Why? Because from the previous example, these are all equivalent. So I don't need to draw. Now this is pretty easy. We already know this. Now let's create our own equivalent fraction. So let's start with a random fraction. Here is 3 over 5. So how do we find an equivalent fraction for 3 over 5? We're going to multiply a number on the top and the bottom of the denominator. And we're going to say multiply by 7. You might be wondering, why 7? Well, this is just a random number I picked. You can multiply with 1, 2, 3, 4, 5, 6. You can multiply 100, but not 1. Okay, you're not going to multiply 1 and 1. You're just going to get the number back. So that's useless. Anyway, 3 times 7 is 21. 3 times 5 is 35. And I can guarantee you guys that 3 over 5 and 21 over 35 are equivalent. But why? Here's something you should know about fraction. If we multiply slash divide both the numerator and the denominator by the same number, we will have an equivalent fraction. But why? Why do we need to multiply the top and the bottom by the same number? Why can't we just not can we why do we need to multiply both the top and the bottom by 7? Why can't we just multiply the bottom by 7 and not the top? Or why can we not multiply the top with a different number, 6, let's say, and the bottom 7? Why? Well, if you look carefully, I want you guys to focus on this. Let me change a color, put it on red. I want you guys to focus on this item. What do we have when we're multiplying? What do we have in fraction when we have a number on the top and the number in the bottom? We get 1. Okay, this is a fraction fact that I want you guys to remember. We talked about this in fraction, and now we're going to talk about it again on equivalent fraction. So why does this actually work? Well, as you can see, when we multiply the top number and the bottom number by the same number, in fraction, what we're actually doing is we're multiplying the fraction with a fancy 1. So essentially, 3 over 5 times 7 over 7 is the same thing as 3 over 5 times 1. But in this case, we're going to get a different fraction. Rather than when we multiply a fraction with a 1, you get the same fraction back. So now the only thing we're changing is this part. We're making this a number over a number itself, fraction. So you might be wondering, why is it different though? This one's way bigger than this, or it looks bigger than this. But however, it's changing its look. Yes, I give you that. However, we're multiplying by 1. So even if this looks bigger than 3 over 5, when you draw it out, they'll have the same amount of picture. They'll have the same amount of shaded area. As you can see, 2 over 8 looks bigger than 1 over 4. But when you compare them side by side and you draw them, they are equivalent fraction. So fraction, you cannot judge fraction by looks. Just because it's using big numbers doesn't mean it's going to be a big fraction. Okay? So I keep saying But before I go to simplifying fraction, I want to talk about dividing. So you can also, instead of multiply, you can divide the top and the bottom number with the same number, and you'll get an equivalent fraction. So let's have another example. Let's say 6 and 12. Here we want to find an equivalent fraction, so we're going to divide both the top and the bottom number with the same number. First of all, when we divide, this is way different from multiplication, that we can just pick any number we want to multiply. Here, when we divide, the number we divide has to be a common factor of 6. So we cannot just divide 5 on both the top and the bottom. It has to be the same factor. It has to be a common factor between 6 and 12. So 3 is a good choice. 6 divided by 3 should give you guys 2. 12 divided by 3 should give you guys 6. Another misconception of doing equivalent fraction when they're doing things is when you're doing this. So let's say we have 7 and 15. And you want to find an equivalent fraction by division. So what they do is divide 7 on the top, and they're going to divide 5 on the bottom. And they're going 1 over 3. That's a common mistake a lot of students do. And what's the problem here? The problem here is that 7 over 5 is not equivalent to 1. 3 over 3 is, but not this. Hopefully that clarifies you on the multiply and divide part. Now let's talk about simplifying fractions. Simplifying fractions should be easy for you guys if you understand the things about greatest common factor. Okay, if you're a lot of you guys scored a high score on your 4.1 and 4.2, so hopefully simplifying fractions should be a bit easy for you guys. If not, then I want you guys to brush up on that, because fractions and GCF goes together like peanut butter and jelly. Anyway, what do you mean simplifying fraction? Simplified fractions are when your fraction, denominator and numerator have no common factor. So that means they are relatively prime. So first of all, let's start with the exercise. Let's choose fractions that are simplified. So let's look at fractions and think, are they simplified or are they not simplified? 1 over 7. 1 and 7 have no common factor, hence they are simplified. How about 6 and 15? From the bat, I already know that they have a common factor of 3, because I know my I know my multiplication table. So they are not simplified. How about 13 and 39? You might think, oh, 13 is a prime number. They don't have it anymore. Boom. However, you're forgetting that 13 can go to 39. That means they are not simplified. How about 5 and 11? Well, that's easy. They are already simplified. How about 23 and 42? You might think, oh, 42, 2 goes to 42. However, think to yourself, does 2 go to 23? The quickest way to do this, the quickest way to do this is, does 2 go to 23? No, so they are already simplified. Here's some tricks for you guys to remember. Hopefully you guys know this already, but if not, then here's a good way to do this. Where's my drawing? So if a number is If you want to see if a number is divisible by 2, both number has to be even. So that's the fastest way to think A. They're both even, so they are divisible by 2. That means they have a common factor of 2, if you guys didn't know. Anyway, there are other ways to find other divisible facts, but you can search it up on the internet, or I can upload it on my website and on the Google Classroom, so you guys don't really need on that. But you can use that as cheat sheet to automatically think, oh, is this simplified or is this not simplified when thinking about fraction? Now let's talk about simplifying fractions. So first of all, there's 2 steps, pretty easy. Again, this is for small numbers, because don't do this for big numbers, it's gonna be so difficult and time consuming. So first of all, first step is find the GCF. Find the GCF of the numerator and denominator. And then second step is divide both numerator and denominator by the GCF. So 12 and 15. So your GCF should be 3. Yep, that's 3. Excuse me. So what do you do? Well, you're going to divide both the top number and the bottom number by 3. 12 divided by 3 should give you guys 4. And 15 divided by 3 should give you guys 5. 4 over 5 doesn't have any more common factors, so that's your final answer. Moving on, 30 and 50. So the GCF here is going to be 10. So next is divide both the top number and the bottom number by 10. 30 divided by 10 should give you guys 3, and 50 divided by 10 should give you guys 5. And that's your final answer. Because 3 and 5 doesn't have any more common factor shared. Now let's say we have 18 and 54. Here we're going to assume your step 1 is incorrect. Hopefully your step 1 is not incorrect. So first of all, let's find the GCF of 18 and 54. So most of you guys will probably answer 9. And that's okay, just pretend your GCF is 9. So what do? Divide both the top and the bottom with 9. (18) divided by 9 is 2, and 54 divided by 9 is 6. Now, are we done? Think to yourself, 2 over 6, 2 and 6, common factors, yes or no? Yes, they share a common factor. And that common factor is 2. So we continue on. Divide both the top and the bottom with 2. You don't need to restart from 18 over 54 to find the simplest form. You just can continue from your previous answer, 2 over 6. Okay, it's not the end of the world if you didn't do the right GCF, but it is the end of the world if you don't continue forward. So continuing forward, 2 divided by 2 should give you guys 1, and 6 divided by 2 should give you guys 3. So your final answer is 1 over 3. So your answer was supposed to be, for step 1, is actually 18. So when you divide 18 and 54 with 18, you'll get 1 over 3. Again, if you chose the wrong GCF, Now, it's not the end of the world for you guys to start and restart from the very beginning. However, you still need to continue on reducing your answer as much as possible. Okay? Um, now, you might be some of you guys learn the other way to the simplest form. Let me erase some of this, and that is using factors. Okay, this is one way to do simplest form. The step is still the same. The first step is you're going to find the GCF of 12 and 15, and we already know that it's going to be 3. It's always going to be 3. Now, what do we do? Well, first of all, we write the fraction. We're the 12 over 15. Now, we're going to find the factors of 12 and 15 using 3. We know that 12 and 15 has a factor of 3. Now we're going to find the missing factor. What is 12? What is 3 times something is equals to 12? That's going to be 4. What is 3 times something equals 15? Well, that's going to be 5. And when we're here, what we're going to do is we're going to cancel the top number and the bottom number together. Why is that? Well, again, this basically is equal to 1. So we're just going to simplify them right here. 3 becomes 1. This 3 becomes 1. Again, they had to be partner, top and bottom, never bottom or top. Now, afterwards, when we cancel most of the things we can, we're going to multiply across 4 and 5. And that's one way to find your simplest form using factors. Some teacher probably taught you guys this, and that's okay to continue using this. If you guys didn't know this, then this is another way to find simplest form using multiplication. Now moving on, 30 over 50. Again, your GCF is 10. 30 over 50. Again, we can rewrite 30 and 50 as 10 times 3 and 10 times 5. Now we cancel 10 out. We simplify 10 out. That's one way I like to say that. We simplify 10 out. 1 times 3 is 3. 1 times 5 is 5. So we can simplify 30 over 50 as 3 over 5. And you can do the same thing with 18 and 54, but let's run out of time. Let's continue on. Let's say we have large numbers and you don't want to find the GCF of large numbers because it's too time consuming. This 18 and 54, that's pretty easy. But what if you have big numbers? You don't want to find the GCF. What are you going to use? Prime factorization. That's the reason why we learn prime factorization in the first place. Not to find GCF, but to simplify fraction. That's okay. Yes, you can still use GCF. Use prime factorization to find GCF, but prime factorization to simplify is the main reason why we learn prime factorization. Here we're going to find large numbers, large fractions. So here is 4 steps. First is find prime factorization of both number and denominator. Step 2 is rewrite the fraction as a prime factor. And then step 3 is cancel out the factors that appear on both numerator and denominator. And step 4, multiply the remaining factors that remains. So it's like kind of like this, but instead of 10 times 3, 10 times 5, we're going to use the prime factors. So here we have 30 and 108. As you can see, you don't want to find the GCF of that number. You have three digits and 2 digits. That's too difficult, even for me. So what do? Do the factor tree. Do the prime factorization. 30 is 2 times 15, and 15 is 3 times 5. How about 108? We have 2 times 54, and we have 2 times 27, and we have 3 times 3. So if you write that, 300 over 130 over 108 can be written as 2 times 3 times 5, and 108 can be written as 2 times 2 times 3 times 3. Now we cancel the number that appears on the top and the bottom. So we can cancel this 2 out and 1, 2 in the bottom. Now you cannot cancel 2 here because there's no more 2 on the top. So let's move on to 3. Hey, there's 3 in here and there's 3 in the top, so we can cancel them. Boom, cancel, cancel. Oh shoot, times 3, another 3. Okay, now you might be wondering, hey, we can still cancel 3 and 3 out together. However, this pair of 3's are on both of them are in the denominator, and we cannot cancel bottom, only top and bottom, or bottom top. Not top, bottom, top, bottom, top. Sounds like a song. Now what do? Multiply across. Here we're left with 5, and 2 times 3 times 3 should give you guys 12. So this is the simplest form of 30 over 108, 5 over 12. About 124 and 744. That's a lot, big number. How do I do that? Well, first of all, let's write 124 and 744 right here, and let's find the factor tree. That's 2 and 62, and that's 2 and 31. Now 31 is a prime number, so we stop. Now let's start with 744. Is 2 times 372, 2 times 186. 186 is 2 times 93. 93 is 3 times 31, and 31 is a prime number, so we stop here. Now we can rewrite 124 as 2 times 2 times 31, and 744 is 2 times 2 times 2 times 3 times 31. Now we can cancel things out. This is my favorite part when we're multiplying fractions or simplifying fraction, canceling things out. And I hope you guys will like it too, because it's so fun. This is the only fun thing I like about fractions. You can cancel things, boom, cancel the top, boom, both of them becomes 1. Again, when we cancel things out, it doesn't turn to 0. They turn to 1, okay? So students think they turn to 0, but in actuality, they turn to 1, okay? Now cancel this 2 out, this 2 in the bottom, and now, is there any more? Yes. We can cancel 31 and we can cancel this 31. So now we're left with 6 in the bottom, 2 times 3. But look at the top. We canceled all the numbers. What do we do? Well, when we cancel things, all of the top numbers, we're not going to get left with 0, but we're going to have 1. So 124 over 744 can be actually reduced as 1 over 6. And that's a simple thing. Is there any... Hopefully you guys learned a lot on this video. Hit that subscribe button, like and subscribe. Anything else, I'll see you in the next video. 3.4, 3.5. Peace.